and this will be presented by Chris Wigget, who's the head of data and analytics at NTT Data, which is part of Dimension Data. So please give him a warm round of applause as he makes his way on stage.
Yeah.
Things from
350, I'd say that's why I can go for range here, 350, 450. Then
But I'm really privileged to be here and talk a little bit to you about what we are busy with and the crazy world of, I think, edge, the crazy world of data and how it all applies to manufacturing, I suppose, as one of the industries. Now, although I only have 20 minutes and it's big, bold in red here, so I'm under pressure, there's always time for a story. And I'm going to start with a personal story. So you see, one of my hobbies is I try and build, mostly unsuccessfully, automated trading robots. Because I believe that alchemy is something we can achieve. But mostly unsuccessful. So the story relates to that. In 2009, a certain trader in Chicago realized that because there's two exchanges in the US, one in New York and one in Chicago, the flow of information and the latency or the lag in information is quite important and quite valuable. At that point, the lag or the latency for data or news to flow from New York to Chicago was 17 milliseconds. Now, if we talk about edge, connectivity, compute at the edge, and all of those things, latency is why we do it. Now, what is latency? Latency is the time that a certain signal travels over a certain distance. To put it in perspective, 17 milliseconds between New York and Chicago. The wink of an eye is 50 milliseconds. So it's quite fast. He realized that if he could put in a very straight fiber connection between these two cities, he could reduce it to 13 milliseconds, 4 milliseconds improvement, worth absolute millions. Managed to convince Sprint to do it, and they invested $300 million, and they built this very straight as possible fiber optic line. He sold it for millions to a limited number of brokers. So that was 2009, a long time ago. In 2014, I was sitting in my study, reflecting on why my robots are not working, and it was obvious. I've got a latency problem. It's not my fault. Latency is the issue. So I installed a tester, and I managed to establish that my latency between my laptop and the exchange in London was 495 milliseconds. Obviously, that is the issue. So in a moment of pure ambition, I phoned my broker and I said, I need to get my latency down. And as I was speaking to him, I remembered how much that reduction in latency 5 years ago was sold for, and realized that I would probably not, I need to get off this call quite quickly. And he said to me, no, we can do it. Because you build trading robots, all we do is we install the trading robot in London, and we can give you 5 milliseconds. Now that's, they went from 17 to 13, I can get down to 5, and nervously I said to him, how much will that cost? And he said, $30 a month. I said, that's great news. I paid my $30 a month, installed it. Apparently, as it turns out, latency was not my issue. So I'm still a very unsuccessful automated trading robot builder. Why I tell this story is all of these things. Now, I live in a world of data and analytics. We're absolutely obsessed with the world of AI. We spend most of our waking time and sometimes sleeping time thinking about it. But all of these things that we do, the impact is in latency. We need to get latency down. Now, latency is milliseconds, as I explained, in most cases. But it can also be a day. And then it becomes lag, rather. What is the time between something happening, us knowing it, and reacting to it? Let's call that human latency for a second. Now, with recent advancements in networking speed, I think the world is changing. Because up to now, and we talked about what is the impact of robots and can we coexist. Up to now, yes. Because what we could do is we could sense faster than a machine. Typically, current networks in a manufacturing environment, if you want to average it out, working on around 100 milliseconds. Now, 100 milliseconds is, and sorry, you guys can go to the next slide. I get carried away. You'll see it. 100 milliseconds, and the next, thanks. There we go. 100 milliseconds, what does that compare to? Well, we have to compare it to us as humans. Now, very difficult to establish what is human latency, but research has been done, and if you look at hearing, typically about 30 milliseconds. If you look at visual latency, which is the fastest of all our sensors, 13 milliseconds is the best. And that was established from pro gamers. So those weird youngsters sitting with the headphones playing these games and earning a lot of money a year out of it, they typically operate on a visual latency of 13 milliseconds. So as compare that to 100 milliseconds, that's where we still fit in. We're better. But not for long. Because along comes new technology, new networking technology. Probably the most important one is going to be 5G. If you look at private 5G networks, the promise is 10 milliseconds. So this is important because all of a sudden, that machine can sense faster than us as humans. For us as a human race, this is profound because we know that computers can store and process data a lot faster than what we can. Now they can sense. So what we're really dealing with here is machines that can sense. The impact of this, once again, is going to be quite significant. Latency is it. When we talk about real-time data, real-time decision-making, it doesn't exist. The enemy here is latency. Next slide, please. Here we go. Got it, thanks. Okay. So now my talk gets a little bit weirder because we're going from manufacturing, we're going from latency, and we're going to this most amazing event. Any followers of Tour de France? Great. Tour de France is something I've followed my whole life. I am a bit of a cyclist, a bit like the trading robots, not very successful, but I do try. Now, we live in a world where, at the moment, we follow, and the tour ended on Sunday, currently the ladies' tour happening, but we're in that sad position where we watch the tour in data. If you come to our offices, you'll see that we've got a war room, we've got an operations center, and the actual video feed is very small. What we do is we follow it in data. Because 5 years ago, we were tasked by NTT, who then at that point entered into agreement with ASO, the cycling organization, and they said, can you connect all of this up? Now, there's many words when we talk about connectivity, connected industry, edge as a service. All of those things are important. Now, the Pyrenees and the Alps are great for cycling, but they're not great for data. Because what you typically have, somewhere between 200 and 300 cyclists riding around 3,000 Ks through Europe in some of the most unfriendly data environments you can find. So we said, okay, cool, we'll give it a crack, and this was about 4 or 5 years ago. And what we wanted to do is build a solution that could become a connected industry solution. Because if we can solve this problem, we can solve a lot of problems in manufacturing, in logistics, and all kinds of industries. Because latency is the key. The other ask was, if you follow the tour, you'll know that some of these stages can last for hours, and those poor commentators have to come up with content. And that's why they talk about the chateaus and this beautiful town, because they run out of content. So we had to come up with new content, and that we could become discussion topics for them. So first challenge is how do we get this data to a place that we can deal with it? Interesting challenge. What we eventually settled on is if you follow the tour, you'll see underneath each rider's seat, there's a small little device. And that really is a telemetry device that only gives position, gives GPS position every every 3 seconds at the moment. That data we need to get into a central place where we can start deploying our models on it. So the only way we could do that is to bounce that data from each bicycle to a number of places, either a team car or one of the motorcycles around. From there, it's bounced up into the air. Over the Tour de France, there's always some aircraft, either a chopper or a fixed-wing aircraft. From there down to a bus, a data bus that we have parked somewhere on the stage, and from there into the cloud. In the cloud, we have our real-time models running, and these models do a number of things. First of all, they will predict, before the start of a stage, top 10 finishes in order. Now, from an AI perspective, that is near impossible. And when we were tasked with that first one, you can imagine the sense of panic when we deployed it the first time. Very, very accurate. We're very, very proud of it. And in this recent tour, we had an event at the campus, and there were 40 cyclists. And they all disagreed with our prediction halfway through the stage. And it turned out the machine was right. The next one was, can we predict whether the peloton will catch a breakaway? And then the last one is a algo that we built, and we called it Le Buzz, because we wanted to make it sound French, you know. And what Le Buzz really is we look at the shape of data. We don't try and look at the granularity. We look at the shape of it and how it changes over time. And from a practical perspective, that means the tour. That means the peloton. How's the shape of the peloton changing? We managed to reduce that to numbers, and a strange thing started to happen. As we were running Le Buzz, we could see that it was changing, it was spiking. And when we watched the video, nothing was happening. And we thought, oh, it's not working. And 3 minutes or so later, something happened. There was a breakaway, there was a turn coming up. So what we saw was that this organization, or this animal that's called the peloton, started behaving in anticipation of something. The Buzz became a great success. It's running at the moment on the tour. All of this is built on a platform. Platform we call Rapid Analytics Platform. When we started this process, we knew, although we built it for the tour, there's bigger application. All of those, that whole process that I talked about, from the time that we get a ping from a bicycle to the time that we deliver content to either apps or the commentators, is sub-second at the moment, latency. So latency, once again, becomes important. Now, the RAP platform has now been built out into an IoT platform, where we can ingest almost any data, and in near real time, sub-second, I mean, if we talk milliseconds, it's not nearly good enough, but sub-second is quite good. And what we are able to do is, in a manufacturing environment, and many other industries as well, we are able to start saying, something is happening, something is changing in this environment. And our full aim and our only aim through that is to make sure that we reduce the time from when something happens until we are able to react to it. Once again, something very profound is happening. Machines that sense. Where we fit in, I'm not sure anymore. I'm going to talk a little bit about, a lot has been talked about in the first sessions about what is happening to humans, what is going to happen to employment. The impact is going to be enormous. I think we all have a responsibility to try and manage that to our best ability. If we look at youth unemployment at the moment, it's at scary numbers. Well, let me give you a couple of other numbers. We run a technical accelerate program at DD, and what we do is we take recent graduates currently unemployed from previously disadvantaged backgrounds, and we take them through a year program. The scary thing is that you've got your pick of engineers, chemical engineers. We currently have 2 young ladies, both with a master's in astrophysics, because we believe astrophysicists can look at data in a different way. We've got such enormous talent and such enormous skill in the country. What you have to do when they come out of varsity is you have to rejig them a little bit. Because I think that our tertiary education system perhaps is not as practical as what it can be or should be. So enormous challenge for us, enormous opportunity. How can we have chemical engineers unemployed? There's lots of them. So I think as industry we all have a absolutely enormous challenge and a responsibility to do our part there and make sure that we skill them up and that we get them into business as quick as possible. Right, so now I get to the more boring stuff. And what I've got here is really, if you look at our solution, and our solution is very much based on the global solution that NTT is rolling out. If you look at the industries that we are targeting, and the others are quite important, manufacturing, healthcare, logistics, mining. I think a lot has been done in mining. I was speaking to one of my fellow panelists earlier, or yesterday. Fully automated mines, run from an operations center. That's happening already. What is the impact going to be on manufacturing? Impact is going to be absolutely enormous. The person that makes the decision after an event the quickest will win. Because the impact on revenue and the impact on cost is unquestionable. So again, I drift back to the latency issue. As you can see, and I'm not going to go through all of that, but there are many areas that are involved in new technology and how it applies to those industries at the top. I'm going to touch a little bit on private 5G. Private 5G as opposed to normal 5G, if you like. Private 5G is a localized environment that can be deployed in on your site. The impact of this is once it starts rolling out, and we very much geared up and we'll start rolling out the first ones quite quickly. The impact is going to be absolutely enormous. First of all, latency, which is probably the most important one for us. Our ability to put many more devices into an environment. If you look at it from our perspective, especially in outside environments, mines, private 5G signals can be pushed 25 Ks. That is not possible right now. You're looking at devices with a battery life of 10 years. Imagine in your manufacturing environment what you can do if you can put a device that can reach so far and can last for 10 years. The data that it will generate for us will be absolutely enormous, and the decisions that we'll be able to make out of that even more so. So let me go back to latency and to edge, because edge is important, but it's not always that applicable. So any one of you that arrived here today with a car that's got dynamic cruise control, blind spot detection, let's use blind spot detection. Lots of cars have got that at the moment. So imagine for a moment the technology behind blind spot detection. Some of it works with radar, some with cameras. Let's take the camera. Somewhere in that car, we've got a machine running, a model running that keeps an eye on that video feed the whole time. It will judge which cars are approaching, what is their speed, and it will warn me. That is quite cool. That is at the edge, 100% at the edge. I battle to find an application that is equally cool in business. We're so far behind. We have to make that leap into that edge environment. However, what is important is, and I'm definitely not here to tell you to say, invest in all of those things before you can reap the benefits. Because we can start with what we have already. You already have networks deployed, you already have IoT devices deployed. And latency in most of our cases is not getting it down to seconds or milliseconds. But it's more about knowing what is my latency, what is my lag that I have at the moment. If it's a week, let's get it down. If it's a day, let's get it down. Because again, and with that I'll end, The competitor that makes the fastest decision will win. No doubt about it. Thank you so much. Thanks, Ellie.